Well, hello and welcome to our final lesson for Chapter 8 in our textbook. If you can see on the screen, it says Lesson 8.8, Solving Inequalities. So if you could write that down in your notes, that would be great. If you recall, inequalities are the signs that look like alligator mouse that we learned when we were in primary grades. We have the less than, the greater than, less than or equal to, greater than or equal to. So that's what we're going to talk about today with our inequalities. Now, for those of you that have been in my homeroom, you're going to be very familiar with how I'm going to have you solve these today. And for those of you that aren't in my homeroom, I'm sure your teacher does something very similar. All right, so an inequality is obviously a math statement that has an inequality in it. It looks very similar to equations. The only difference with an equation is there's an equal sign. So for example, this would be our equation. We're going to solve inequalities the exact same way we solve equations. We're going to find our balance. Our balance is our inequality. So we'll circle that. Then we're going to look on both sides of our inequality. On this side we have a 5. And on this side, we have an x minus 4. Which side has the variable? Well, this does. This has x. Is the x by itself on that side of the balance? No, it's not. It has a minus 4. The opposite operation of minus 4 would be plus 4. So in my classroom, we add 4 to one side. And obviously, whatever we do on one side of the balance, we have to do on the other side of the balance. Opposite operations will cancel, leaving x. 5 plus 4 is 9. And then all we do is we bring our inequality sign straight down like this. Now, if I wanted to graph that, we could just make a real simple little graph for today. We'll just put 3 tallies. We'll just put a 9 here in the middle. This shows that we are going to do an open circle, because there's no equal to sign, and it says x is greater, and the arrow is pointing this direction, so our line is going to also go that direction because we are going greater than 9. Okay, well, sometimes our inequalities will not only be subtraction, they might be what we call addition. So I could say here y plus 2 is greater than or equal to 17. Do the same thing. We find our balance or our inequality. We circle it. On this side is 17. On this side is y plus 2. The variable is y. It is not by itself on this side. It's with a plus 2. The opposite operation of plus 2 is minus 2. Whatever we do on this side, obviously we have to come over and do it on this side since this is kind of our balance and we're going to keep things even. Opposite operations cancel, leaving the letter y. And 17 minus 2 is 15. And then all we do is we carry our balance straight down like this. All right, so the next inequality I'd like to solve is this one right here. If you put this in your notes. Once again, we find the balance or the inequality. We're going to circle it. 15 is on one side and 6 plus h is on the other side. So this inequality is kind of reverse of what we had here. So I'm still going to do the same thing. H is over here. It's not by itself. It has a 6. This is a positive 6. In order to get rid of a positive 6, we have to subtract it because 6 minus 6 will cancel. Whatever I do on this side, I have to do on this side. So the 6 and minus 6 cancels, leaving h on the right side. And then we have 15 minus 6, and 15 minus 6 is 9. Bring my balance straight down. Don't flip it. Make sure you leave it the way it is. Now, if I wanted to graph this, I would probably flip it so that I would graph it and not make any mistakes. So for example, I would flip it to do something like this. I want my variable to be listed in the front. This is my variable. This is my number. It's 9. If you notice, the inequality is pointing to the H. So now I need to make sure it's pointing to the H as well. This says H is less than or equal to 9. This says H is less than or equal to 9. All right, well, here's our next inequality. Sometimes inequalities will be written with division and multiplication symbols, just like we did earlier with the addition and subtraction. We solve these exactly the same way. I like to find my balance first, which is obviously my inequality. I circle it. Makes it easier for me to look to see there's no variable on this side. The variable is on this side. It has an x. The operation that's being performed is x divided by 4. What is the opposite of division? The opposite of division is multiplication. So over here, we're going to multiply by 4. And obviously, whatever we do on one side, we have to come over and do on the other side. Most of us know that if I put it 4 over 1, these 4's will cancel, leaving the letter x. 2 times 4 is 8. And what do? I bring my balance right down. So my solution is x divided by 8. I'm sorry, not divided. X is less than 8. So that means any number that's smaller than 8 will fit my solution. Let's look at what a multiplication problem might look like. So for example, I could take and just do 4 times x, because we know that when a variable touches the integer, that means multiply, is less than 8. So we'll turn this around. Well, I'm going to do this just like I did the division problem. I'm going to circle my balance. I find the variable is x. It's multiplying with 4. The opposite of multiply would be divide by 4 on this side and divide by 4 on this side. 4 divided by 4 cancels because they're opposite, leaving a 1x. And 8 divided by 4 is 2. Bring my balance straight down, and my solution is going to be x is less than 2. Now the next thing I'm going to actually do is pull up some two-step inequalities for us. All right, so the next inequality I'd like for you to write down is 2x divided by 3 is less than or equal to 4. Now, the first thing we're going to do, once again, is we're going to circle our balance. We're going to find the variable, and it's x. If you notice, there's 2 integers with it. We have a multiplying by 2 and a dividing by 3. So we have to get rid of both of them. The first one we're going to get rid of is the one that is the furthest away or is not touching the variable. Well, the 2 is touching the variable, so those are pretty close. This one is the furthest away, and so we're going to do that operation first. Dividing by 3. The opposite, remember we have to do opposites. The opposite of dividing by 3 would be we're going to multiply by 3 on this side, and the rule is whatever we do on one side, we obviously have to come over here and do on the other side. Well, this is 3 over 1. These 2 will actually cancel out, leaving 2x is left on the left side. 4 times 3 is 12. And then I bring down my balance, or my inequality. Now I only have one thing left to do. Well, here's my balance still. It's right there. This is multiplying by 2. The opposite operation would be divide by 2 on this side and divide by 2 on that side. 2's cancel, leaving the letter x. 12 divided by 2 is 6. And then I bring down my inequality, and my final answer is x is going to be less than or equal to 6. Now today's lesson, we're going to actually solve these inequalities, and then we're going to put together the lesson we did yesterday, and we're going to graph them as well. What I would like for you to do is I would like for you to use the example we just did, and I would like for you to solve 3b divided by 4 is greater than 6. See if you can solve this inequality right here. Use this one as your example. All right, so if you want to pause your video so that you can complete it, you can, but you will notice I've already circled my balance. The first number I'm going to get rid of that's over here with the variable is going to be the 4 because it's the furthest away. I'm going to multiply by 4 on this side and multiply by 4 on this side. These cancel. This leaves 3b over here. 6 times 4 is 24. Is greater than, 3b is greater than 24. I still have a number touching the variable. So the opposite of multiplying by 3 would be to divide by 3 on this side. Divide by 3 on this side. 3 cancels, leaving b is greater than, 24 divided by 3 is 8. So the solution for this inequality has to be b has to be anything that's larger than 8. Can't be equal to, but it must be larger. All right, so I'm going to do another one like this. I don't want you to solve it yet because I want to show you a different way to solve it for those of my math students that want to do problems a little bit quicker. Okay, this is the same kind of setup as what we had up above here. This says 5x divided by 8 is greater than or equal to 30. Now the other way we could solve this is we could actually take this fraction out and pull it out in front like this. We could say 5/8 times x is greater than or equal to 30. Okay, this is exactly the same inequality. I just kind of pulled the 5/8 away from the x for right now. Now, right now, this fraction is multiplying by x. The opposite of multiplying would be divide. Most of us know if we're going to divide by a fraction, the rule is keep, change, flip. So I'm going to keep the 5/8. I'm going to do 5/8 like this. I'm going to change from multiplying to, or dividing with fractions, is I'm going to change it to multiplication. I'm going to flip like this. I still have my x. I still have my greater than or equal to 30. Because this is the new part that I added, I have to do that on this side as well. So I'm multiplying by 8/5, and I'm going to multiply by 8/5 over here. I have to do exactly the same thing in order to keep my balance equal. So these 8's cancel, these 5's cancel, leaving the letter x. 30 over 1. Let's see what we can do like that. Some of you will actually notice how to cross reduce. You'll notice there's a 5 down here. That 5 goes into 5 once. 5 goes into 36 times. 6 times 8 is actually 48 over 1. And so I just found out x is greater than or equal to 48. Now, all I did was I took this fraction here and I pulled out the fraction away from the x. I got rid of this fraction by doing the multiplying of the inverse, 8/5. Whatever I do on this side, I have to do on the other, and then I was able to solve. If you don't want to do it like this, remember you can always do 2 steps up here. Divide by 3, or multiply by 3, and then divide by 2. Okay, so you have a couple of examples. Now, the reason why I want to show you these 2 examples is for this final problem. All right, so the inequality I have here says 3/5 times q is less than or equal to 6. Now, there's 2 ways we can solve this. We're going to circle our balance here. You can either multiply this by the inverse operation, or you can also change the problem and write it like this. Put 3, go ahead and put the q on the top, 3 times q, put the 5 here, less than or equal to 6. Okay, so now you have to decide how do you want to solve it. If you're going to solve it this way, the opposite of multiplying by a fraction would be to divide. And when you divide, you keep, change, and we're going to multiply by the opposite operation. This is what I added, so whatever I do here, I have to do over here. This cancels, leaving the letter Q. 6 times 5 over 3. Well, if I put this over 1, some of you might just say 6 times 5 is 30 divided by 3. Some of you might actually cross reduce here. 30 divided by 3 is 10. Bring down my balance, and my final solution is Q is less than or equal to 10. For those of you that have a hard time understanding this, you're going to want to do it this way. Opposite of dividing by 5 is multiply by 5 on this side, multiply 5 on this side. These 5's cancel, leaving 3Q is less than or equal to 6 times 5 is 30. Same exact answer, it looks like. Multiplying by 3, opposite is divide by 3. Divide by 3 on this side, divide by 3 on this side. 3 cancels on the left, leaving the letter Q. 30 divided by 3 is 10. Is less than or equal to. Let's see, is this the same? They are exactly the same. So there's 2 ways that you can solve this. You decide which one works better for you. Remember, we're also going to take these inequalities and graph them. So for example, for this one, you'd have to find the 10. Put a circle, but it looks like I have to color it in because it has the equal sign. And it's saying Q is less. It's pointing to the left. So that means we're going to color our inequalities like this. Okay, well, your teacher will tell you what you're going to do now that you're done with your lesson.